Let's dive straight into this explainer, because today we are unpacking a massive story of African self-reliance. We're looking at how some of the most ancient natural systems on the planet are colliding with cutting-edge engineering to tame one of the harshest environments on Earth, the African desert. We're going to break down these incredible mega projects that are quite literally redrawing the map of the continent and see how they're balancing explosive economic growth with some absolutely crucial environmental preservation. But before we talk about what humans are building, we actually need to look at nature's ultimate masterclass in hydraulic engineering, the Nile River. To really grasp our own power over nature, we have to ask a seemingly impossible question. How does a river survive for 30 million years, flowing 2,000 kilometers through the scorching Sahara Desert? I mean, surface temperatures there can hit a blistering 58 degrees Celsius. Without some serious built-in defenses, it should just evaporate into a dry, salty trail. Well, one of the Nile's absolute best-kept secrets is what experts call its hidden twin. Right beneath the river we see, there's a massive subterranean current flowing through the Nubian sandstone aquifer. Think of it like a giant, invisible backup tank holding an unbelievable 35,000 cubic kilometers of ancient water. When the surface evaporation gets too intense, this pressurized underground reservoir literally feeds the Nile from below, keeping it alive. And along with that hidden twin, the Nile survives through three brilliant natural defenses. First, distant abundance. 85% of its flow actually comes from monsoon rains trapped way up in the Ethiopian highlands, not from local rainfall. Second, deep, narrow channeling. The river carves itself deep into the bedrock to shrink the surface area exposed to that brutal sun. And third, it has a self-generated microclimate shield. The evaporative cooling creates this humid, invisible blanket over the water that actively bounces infrared heat away. It's just genius. So, Africa must be built by Africans and African companies. African nations aren't just relying on nature's ancient tricks anymore. They're taking these deep lessons in water management and applying them to their own modern engineering. This quote really hits the nail on the head regarding the massive shift towards South-South cooperation we're seeing right now. Instead of depending entirely on outside help, countries like Egypt and Tanzania are tapping into their own specialized expertise to build their future on their own terms. And the absolute ultimate showcase of this cooperation is the Julius Nyerere Hydropower Project. Built by an Egyptian consortium to the tune of $3 billion, this colossal dam tames Tanzania's notoriously unpredictable Rufiji River. But what's really cool is it wasn't just brute forced. It was engineered with incredibly strict environmental protocols to protect the surrounding Celsius Game Reserve, which is a World Heritage Site. Let's talk sheer power for a second, because the numbers are staggering. 2,115 megawatts. It pulls this off using 9 state-of-the-art Francis turbines. These are highly efficient engines driven by the massive rush of water, and each one has a capacity of 235 megawatts. This single piece of engineering literally doubles Tanzania's electrical capacity. It completely stabilizes their national power grid and gives them the massive baseload power they need for serious industrial development. They're actually calling this thing the fourth pyramid for Egypt. It safely manages a 34 billion cubic meter reservoir, making it Egypt's largest engineering undertaking in Africa. But we have to look past the concrete. It's a strategic developmental partnership meant for real regional integration. It goes way beyond just trading goods. It's about locking in mutual food and water security for both nations. Look, true development isn't just about building a dam and walking away. It is about empowering the people who live there. This project created over 19,000 jobs, mostly for Tanzanians. By setting up dedicated vocational training centers right on site, they are transferring critical technical knowledge directly to local workers. This means Tanzanian engineers will be able to run this facility entirely independently for generations. It proves that if you want lasting success, you absolutely have to foster local expertise. All right, let's pivot to Egypt's own turf for a frankly mind-blowing ambition: creating the Qattara Sea. The Qattara Depression is this massive, hyper-arid basin that sits 197 feet below sea level. The plan? Channel seawater directly from the Mediterranean into this depression to create a gigantic artificial lake covering 7,700 square miles. I mean, this is a project that would fundamentally redraw the entire economic geography of Egypt. You're gonna love the history behind this because it is wild. Back in 1964, during the Cold War, the CIA actually pitched a plan to use 213 nuclear bombs to blast a canal to the depression. Yeah. Egypt rightfully passed on that terrifying idea because of, extreme radiation and seismic risks. Fast forward to today, and modern engineering offers a much safer route: tunnel boring machines. These things are essentially mobile underground factories, some as long as 14 buses that precisely carve through solid rock to safely let the seawater flow. And the energy implications here are just massive. This setup will act as a giant natural battery, using pumped storage hydroelectricity between the high plateau and the depression below. It's literally the linchpin that will help Egypt hit its mandate of 42% clean energy by 2030. They can store surplus wind and solar energy by pumping water up and then release it through the turbines when the grid needs it most, drastically cutting their reliance on gas. This new artificial sea is designed to be a complete industrial nexus. We're talking co-locating reverse osmosis plants to desalinate fresh water on a massive scale. On top of that, they plan to filter highly valuable lithium out of the saltwater brine to feed the booming global electric vehicle market. Throw in new commercial fisheries and the fact that all this water will increase local humidity and moderate the climate, and you've got a total environmental transformation. Now, zooming in from massive lakes to the micro scale, we're seeing brilliant ecological engineering across the Great Green Wall initiative. Local communities are fighting desertification using brilliantly simple grassroots tools. You've got side pits, which are these crescent-shaped holes that force rainwater into the ground to restore dead, hardened Sahel soil. Then there's sand dams, storing millions of liters of water safely underground away from the sun. And just arranging simple contour stone lines to slow runoff is boosting crop yields by up to 80% in places like Burkina Faso. And hey, these microengineering techniques aren't just an African thing. This kind of biological engineering is a global necessity. Take Nevada, for example. Researchers there discovered that a tiny ground-dwelling insect called the alkali bee is literally the only pollinator heavy enough to trigger the spring-loaded mechanism of the alfalfa flower. Restoring the habitat for that one highly specific local pollinator turned out to be the absolute key to seed production and reviving the entire local ecosystem. So whether we're restoring local bees or generating gigawatts of hydropower, connecting all these new flourishing zones requires serious logistics, and that relies entirely on the unforgiving manufacturing of steel rails. It's a massive industry expected to top $20 billion globally, but it's not easy. It demands precision iron extraction, smelting at over 1,200 degrees Celsius, exact pressure rolling, and rigorous ultrasonic flaw testing to make sure these rails can handle decades of heavy freight without breaking a sweat. So, what should we take away from all this? Ultimately, sharing these varied engineering triumphs provides a peaceful, intensely practical framework for diplomacy. It is a genuine blueprint for South-South cooperation. By focusing heavily on mutual economic integration and shared prosperity, nations can effectively resolve tense regional issues. It's a collaborative alternative to acting alone, and it offers a real pathway to ease geopolitical friction, like the GERD dispute, through mutual benefit. As we wrap up this explainer, I want to leave you with this thought. We've seen how the Nile has flawlessly managed its own incredibly complex hydrological cycle for 30 million years. Now, as we step in to carve new seas in the desert, lay down steel arteries across the continent, and tame wild rivers with billions of dollars of concrete, the ultimate question remains: can our modern engineering truly harmonize with those ancient natural forces over the long run? Thank you so much for exploring this with us.